Welcome back to day 11 of our final exam review unit for algebra. For today, you're going to be needing your graphing calculator and also a ruler. All right, so let's go ahead and take a look. Our goals for today, number one, given any equation and your calculator, you will be able to graph the equation. And number two, given any equation, you will be able to calculate the average rate of change between 2 points. All right, so let's start off just graphing. So if we take a look here, it says sketch the graph of the function y equals the absolute value of x plus 3. So what we're going to do first is we're going to go to our calculator and we're going to plug in the function. Now, to get to the absolute value, you hit second catalog, which is your 0 button, and absolute value is going to be the very first choice. So you just hit enter when that triangle is next to it. Okay, now we're going to go ahead and we're going to type in an x. And then we go over, and then we're going to go plus 3. Now let's hit graph just to take a look. So this is what it's going to look like, but I need to find points that I can use to actually put that on my own paper. So I'm going to look, it looks like the middle of the graph is around x is 0, so I'm going to use that as the middle, and I'm going to go to my table of values. So we said the middle was about 0, so now I want to go 3 values below and 3 values above. So there we go. So I'm going to use negative 3, 6, 5, 4, 3, 4, 5, 6. All right, and now we can go ahead and we can plug in, or we can plot those points. All right, and then we use our ruler, and we're going to connect them with a nice straight line. Now we want to make sure that we remember our graphing etiquette, so we have arrows because we know that these are functions, they go on forever. And then we want to make sure that we label at one of the arrows. And we've got it. This is our absolute value function. All right, let's take a look now at example number 2. It says sketch the graph of all of the solutions to the equation y equals 1/4 2 raised to the x power, where 0 is less than or equal to x, which is less than or equal to 5. And then we're going to find the average rate of change between f of 2 and f of 5. Okay, so let's first start with the first part of this question, which is just to simply graph. Now, it's telling me right here that I only want values between 0 and 5, and this is my x, so this is the domain that they want me to use. So I'm going to go off to the side, and I'm going to write myself a table of values. And we're only going to go from 0 to 5. So 0, 1, 2, 3, 4, and 5. Now I'm going to let the calculator find those values for me. So I'm going to go 1/4, and then in parentheses 2 raised to the x. And then I'm going to go to my table of values, and there we go. So 0 is going to be 0.25. 1 is 0.5, 2 is 1, 2, 4, and 8. I'm going to hit graph so I see. It's going to be a nice exponential function there. So let's go ahead now. We're going to plot only these points. So 0.25, 1.5, 2 is 1, 3 is 2, 4 is 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm going to connect these, but I am not going to continue my line with arrows. It stops. It only goes from here to here. And now we have graphed our exponential equation between 0 and 5. All right, let's take a look now at part 2. Find the average rate of change. Now remember, average rate of change, this is a fancy way for saying slope of a nonlinear function. So we're going to use our slope formula here. So in order to use the slope formula, I need to have 2 points. Now remember, from our video on functions, we know that the values inside of the parentheses are your x's. So my first point is going to be the point 2, comma, now if I come over here, it's 2, 1. And then my second point is going to be 5, comma, and I'm going to look over here, 5, comma, and it's going to be 8. And now I'm going to use the slope formula, the average rate of change, to find that out. So we know it's change in y over change in x. So that's going to be 1 minus 8 all over x minus x, 2 minus 5. We get negative 7 all over 2 minus 5, negative 3. But remember, a negative over a negative turns into a positive 7 over 3. So 7 over 3 is your average rate of change, aka the slope between f of 2 and f of 5. All right, let's go ahead and flip to the back. Okay, example number 3. So here we have another function. So this is called a square root function. So draw the graph of y equals radical x minus 1 on the set of axes below. All right, now in this case, they didn't give us a domain, so we're going to have to put arrows on our graph. So the first thing I want to do is I want to see what this looks like. So I'm going to go square root of x, use my over arrow, and then minus 1. So make sure that minus 1's not underneath the square root symbol. Then I'm going to hit graph. Ooh. So it looks like it stops right here at the x-axis and it kind of gradually goes up. So I'm going to go to my table of values now. And if I see, ooh, look at that. So whenever it's negative, there's an error. So that means our function does not have negative x's. So we're going to start our x's at 0. And then, so it's going to be 0, negative 1. Okay, now I'm going to look for just my whole number. So let's see, we have 1 and 0. And then if I take a look, so I'm going to skip 2 and 3 because those are irrational numbers. So I get integer values here for 4 and 1. So we can be a little choosy on the points that we use. There we go. So 9 is 2. And if I go down, keep going. Oh, there we go. 16 and 3. So we don't have to use every point in the table. We can pick out the points that we want to use so that way it's easy to graph. All right, so let's go ahead now and let's graph these points. So 0, negative 1, 1, 0, 4, 1, 9, 2, 9, 2. All right, I can't fit 16, 3 on my graph, so I'm going to stop here. So remember, we don't have any negatives, so I'm going to start here. Continue up with a nice, easy, gentle curve, and then we put an arrow. So we have this nice square root function. And remember, at the arrow, we're going to go ahead and label our graph. And I'm going to hit graph one more time just to double check to see that I'm matching with the function. And that is our square root function. All right, let's take a look now at number 4. A population that initially has 20 birds approximately doubles every 10 years. Which graph represents this population growth? All right, well, instead of guessing, I'm going to go off to the side and make myself a table of values. So it says the population initially has 20 birds. So at time 0, it's at 20. Now it's going to double every 10 years. So in 10 years, now instead of 20, it's going to double and we're going to have 40. Now in 10 more years, so that'll be 20 years, now we're going to double this again. So this is going to become 80. And then in 30 years, skipping here, 30 years, we're going to double this again to get 160. Okay, and then in 40 years, we're going to double that again and have 320. So now we want to see, well, which of our graphs is going to have these points on it. So let's take a look at number 1. Here we start at 0, 0. Well, here we started at 0, 20, so it can't be that. Number 2 starts at 0, 20, but here it's going down, and we want our values to go up, so it can't be 2. Next, we have number 3. Here it starts at 20. Then at year 20, let's see, are we at 80? We're at 80. At year 40, oops, we're going to be way up there, so I think that's going to be our answer there. Let's just double check to make sure 4 doesn't work. So 0, 20, that works. But 20 is supposed to be at 80, and here if I go up and I go over, we're only at about 40 here, so that's not going to work. All right, last question. The graph of the equation y equals ax squared is shown. If a is multiplied by negative 1/2, the graph of the new equation is, okay, well, let's go ahead and let's double check here. So it has y equals ax squared. I'm going to assume that a is going to be equal to 1. So I'm going to type in 1x squared. So let's see what happens when I multiply it by negative 1/2. So negative 1 divided by 2 and then x squared. Let's see what happens. Let's hit graph. So here's my original, and here's my new one. So it looks like it flipped upside down, and it looks like it's wider this time. So let's see if that actually is one of our options, wider and opens downward. That's option number 1. All right, ladies and gentlemen, our goal for today, given any equation, you'll be able to graph and find the average rate of change. We've just accomplished both of those. Have a great night, and I'll see you all tomorrow.